We're going to be looking at similar triangles today, and we're actually going to start off by talking about congruent triangles and reminding ourselves about that. So here's a review about congruent triangles. So the definition, or a definition, two triangles are congruent if all 6 pairs of corresponding parts are congruent. So we needed all 6 pairs according to the definition. But as we learned earlier, we actually don't need all 6 pairs of corresponding parts to prove that the triangles are congruent. We talked about and learned other ways to show triangles are congruent, and those you will remember were side, 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 angle, 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 side, and the HL theorem. So just like we didn't need all 6 pairs of corresponding parts to be congruent, we don't need the entire definition of similar to show that two triangles are similar. So by definition, two triangles are similar if corresponding angles are congruent and measures of corresponding sides are proportional. So that's really still 6 pieces of information: the ratios of the sides, and then the angles being congruent. But once again, we don't need all that information. We're going to have some other ways to show triangles are similar without using everything that's part of the definition. So our first one is called angle similarity postulate, abbreviated AA. If two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. So this tells us if we just know two angles are congruent, two angles of one triangle are congruent to two angles of another, then those two triangles have to be similar. Well, we might think, well, why don't we have 3? Like in the congruent postulates, we needed 3 things to be congruent. Here we only need 2 angles to be congruent. So why only 2 angles? Well, in this picture here, these 2 triangles are similar because we have this angle, angle A, is congruent to angle C, and then we have the vertical angles here that are congruent. Angle BEA and angle CED are congruent. So by this postulate, they're congruent. And the reason we only need 2 angles is by the third angle theorem that we learned a while back, which said if 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles are automatically congruent. So that is our first way to show 2 triangles are similar, the angle postulate. So are these 2 triangles similar? Well, what we would want to do here is see, do they have 2 angles that are congruent? Well, the 92, angle A, is congruent to angle D, so that works out. Angle B is not congruent to angle F, but what we need to do is we need to find out, is angle B congruent to angle E? And so what we should do is find this third angle in our triangle. I'd take 92 plus 57. That's 9. That's 149. 180 minus 149. Gives us 31. So this angle here is 31 degrees, which 31 is not congruent to 41, so these 2 triangles are not similar. This one, it's telling us the 2 triangles are similar. Triangle PQR is similar to triangle STU, and this does tell us that these line up, so P will go along with S and angle Q with angle T, and angle R will go with angle U. So since they're similar, we should be able to find the missing angles. Well, R is congruent to U, so angle U, that's got to be 40 degrees. And we know these angles have to add up to equal 180, so this one has to be 50, as well as angle P has to be 50. So there we have it. There's 2 other ways to show triangles are similar. the side-side-side similarity theorem, we use SSS. We just differentiate between the two because one's talking about similar triangles, the other one's talking about congruent triangles. So that's if corresponding sides of two triangles are proportional. So if corresponding sides of the two triangles are proportional, then the two triangles are similar. That means we needed to show three ratios there and make sure all those three ratios are the same. And then the other one is side-angle side. And here you need an angle of one triangle is congruent to the angle of another triangle. And the lengths of the sides including these angles are proportional. So we'll need two ratios of sides along with an angle being congruent, the angle between the sides we're referring to. So we have three ways to show triangles are congruent. There is ways to show triangles are similar. There's angle-angle, side-side-side, and side-angle-side. Whenever they're talking about angles, the angles have to be congruent. When they're talking about sides, the sides have to be proportional. So, as marked, by which method would it be possible to prove these triangles similar if it actually is possible? Well, looking at this, we have 40, 50, and 60, 4, 5, and 6. So what we do, there's no angles involved here, so we would not try angle-angle or even side-angle-side. So if it's going to work, it's going to have to be side-side-side. So what we need to do is we need to check what these ratios are equal to. So we take the shortest side of the one triangle, and we're going to put that over the shortest side of the other triangle. And then we go to the next longest side, that's 5 compared to 50. And then lastly, we look at the longest side of this triangle over the longest side of the other triangle. And we want to see what those reduce to. They all reduce to 1/10. So since they all reduce to 1/10, they are proportional. So the answer is side-side-side. Moving on, as marked, by which method would it be possible to prove these triangles similar, if it even is possible? Now notice what triangles they're talking about. It's this larger triangle, triangle ABC, and then this smaller triangle on the left here, ADE. Don't get confused, this part over here is not a triangle, it is a quadrilateral. So we are given an angle measurement here. So this angle is congruent to this angle, so it's probably not going to be side-side-side, especially since no sides are given. And since no sides are given, it's probably not going to be side-angle-side. So do we have enough information? We have one angle congruent to one angle. Actually, what we need to notice here is that angle A is part of both triangles. So that angle is congruent to itself. So if we look at triangle ADE compared to triangle ABC, those two are going to be similar by angle-angle. And lastly, the same directions as marked, by which method would it be possible to prove these triangles similar, if it is possible? And probably, if it's going to work, it's going to be side-angle-side because we are given two sides and an angle of each triangle. The 52 is congruent to the 52, so that fits the angle part, and that angle is between the two sides that are in question. And now out of those two sides, we're going to take the smaller, so 2, compared to the smaller one over here, to 10. And then the larger compared to the larger. Are these ratios equal, or otherwise is this proportional? In other words, is it proportional? 2 over 10 reduces to 1/5, and 3 over 15 also reduces to 1/5. So because the angles are congruent, the included angles are congruent, and the two sets of sides are proportional, it is side-angle-side. And that is how we work with similar triangles and how we prove triangles are similar. We have angle-angle, side-side-side, and side-angle-side.